Okay, y'all, let's finish up chapter 3. The phosphorus cycle moves between land and water. If you take a look at the arrows, it avoids the air or atmosphere. Okay, so where does it all begin? Well, it begins with the weathering or mining of phosphate rocks and the use of phosphate fertilizer. Whoa, Mr. Chan, what is phosphate? Good question. So phosphate is PO4 3 negative. So that's phosphate. So it releases phosphorus into the soil and water. This phosphorus can be used by producers and subsequently moves through the food web as seen here. In water, phosphorus can precipitate out of solution and form sediments which over time are transformed into new phosphate rocks. Okay, and you guys can see there. Dissolved phosphate settles over time out of water, turns into rock. So, what happens when there is a lot of phosphorus? Sorry, y'all. Phosphorus. Phosphorus runoff right here causes the local waterways to be, very productive for the algae population. So the algae grows very fast, but then the resources run low, so they die off very fast as well. And then the die-off bacteria uses a lot of oxygen in the water to break down the dead algae. So this creates a zone of low oxygen or hypoxia. Okay, moving on. Responses to disturbances. Let's talk about ecosystems and how they differently respond to disturbances. And then how they respond determines how they bounce back. So, what is a disturbance? A disturbance is an event caused by physical, chemical, or biological agents resulting in changes in population size or community composition. So, just damages. There are natural ones like a tornado, flood, or human cause, like building human sediments for human populations, building agricultural fields also disrupts the ecosystems. So those are disturbances. Resistance, y'all, is defined as a measure of how a disturbance can affect flows of energy and matter in an ecosystem. So high resistance, y'all, means that there's little change to the ecosystem. So I want you guys to write that down. So again, I want you to write it down. High resistance equals little change to the environment. Okay, high resilience we'll talk about in just a second after talking about resilience. The rate at which an ecosystem returns to its original state after um, a disturbance. So high resilience equals uh, quickly recover from disturbance. Okay. And then restoration ecology is the study and implementation of restoring damaged ecosystems to be either turned back to what it once was or use it for another purpose. Watershed studies help us understand how disturbances affect ecosystem processes. So, watershed is defined as all land in a given landscape that drains into a particular stream, river, lake, or wetland. They're also called drainage basin. So, notice y'all, all land given or in a given landscape that drains into a particular stream, river, lake, or wetland, that's essentially everywhere. Okay? Even places with little precipitation is just rare. So, there you have it. Watersheds help us understand disturbances. So, Let's read the overall message. This is the overall message, y'all. Let's read it. Intermediate levels of disturbance favor high species diversity or biodiversity. So let's define that. Intermediate disturbance hypothesis. The hypothesis that ecosystems experiencing intermediate levels of disturbance are more diverse than those with high or low disturbance levels. Let's take a look at graph A. Graph A clearly illustrates this, y'all. So we have the low infrequent disturbance. So that means not a lot of earthquakes, not a lot of volcanic eruption or tornadoes or natural disasters happening. Again, it favors those who are competitors. The best competitors will win because there are no outside disturbances to put a wrench in these competitors' plans. Nothing that would wipe them out, nothing that would slow them down. So these best competitors win. So if the population is only made up of these best competitors, it means that biodiversity is low. So this is species richness. We haven't gone over that term yet. So let's replace that with diversity. Okay, or biodiversity. So biodiversity is low. But as there are intermediate disturbances, y'all, notice that the biodiversity actually increases. But too many disturbances causes the population to decrease again. So this one was the best competitor. Whoops, sorry, y'all. So best competitor. This one here favors species who adapt to the conditions. So evolved to the conditions, or has a high growth rate. Okay, so the best or highest level of biodiversity would be from medium level of disturbance. Some disturbance that does knock out some competitors, but doesn't destroy every species within the ecosystem, thus providing a very, very diverse population in that ecosystem. So let's take a look at the real life example, y'all. This is an example of B right here, the example of the intermediate disturbance in the number of algae species observed in response to different amounts of marine snails. Okay, so when there are few or many snails, notice that the biodiversity is very low within the algae species. But when there is an intermediate amount of snails, and the snails eat the algae, right? Intermediate level. This causes the diversity to be very high. Different types of algae exist at the medium level of snails. So again, few snails means that a lot of the best of the algae would out reproduce the ones that are not very good, the best competitor. Okay, and then for a lot of snails, right, located here, this means that just there's not enough algae to survive, and only the ones that somehow evade the snail survives, and they reproduce that way. But the only snails that can do that are the ones that are in that ecosystem, thus low biodiversity. Okay, y'all, that is it for today. Have a good one, y'all. I will see y'all soon.